Hello everybody and welcome to another enVision's Algebra 2 video. I don't know why that took me so long to say. So this example we're going to go over topic 3, lesson 5, understanding how multiple zeros can affect the graph, and then try it. So when they're looking at multiple zeros, what they're looking at is, let me get to my notebook if I can find it, and the zillion tabs I usually have open. So what we're looking at is something like x minus 2 to the 5th power. And I just chose 5 randomly. This right here is telling me I have x minus 2 times x minus 2 times x minus 2. Why did I choose 5? For reasons my mind knows, but do not know. All right, so we have this written out 5 different times. And what we're looking at is we're looking at this 1, 2, 3, 4. This value of x equaling 2 5 times. And what does that look like? That means that we are actually hitting the graph at x equals 2 5 times. So it's kind of like the graph comes in, here's 2, and it's like kind of like, it's not exactly like this, but it's kind of like it comes in and just kind of bounces in there, up and down, and then goes out or goes back down. So it's again like if this was my zoomed in version, it's like the graph will come in here. This is 5, so it's going to be opposite. So it's going to come in here, and it's going to kind of bounce here 5 times, and then it's going to go off again. So let's see what they gave us. So one of the zeros of the polynomial function is f of f is 1. Use the tool to explore how the multiplicity, and this is what we call it. We call it a multiplicity, which means that it stays within that value multiple times. It hits that value multiple times. Of 0 affects the graph. When the multiplicity of 0 is odd, the function crosses the x-axis. But when the multiplicity is even, it turns back around and goes down. So let's go back here to my image, my very nice image. Get my circle here. So if it's odd, I'm going to use green for odd. It'll come and it'll go through the point and keep going. When it's even, it'll come through the point and basically bounce off and go back down. I used to have a teacher I used to teach with, and he used to say it would kiss the x-axis. So it'd come in, give the x-axis a little kiss, and then go off and do its thing. Kind of like when your parents drop you off at school and they call you back to the car and say, hey, come say bye to me. You come back, you bounce back to the car, and then keep going. So let's look at this. So this is when this a value is equal to 2. So it's 1, then it's 2. So if I were to expand this, I have an exponent or a multiplicity of 2 here, and I have a multiplicity of 1 here. It's not really a multiplicity if it's a 1. So I should technically, with the degrees, have 3 solutions, have 3 times this crosses the axis. But what's happening is because of this multiplicity, I only have 2 zeros here. All right, so we're going to keep going. That is for 3. Again, we still have the 2 zeros, even though I have 3 for A and 1 here, which is 4. I should have 4 solutions, but I still only have 2 because what's happening in here, and you could kind of see if I zoom in and how this is kind of getting a little flatter. It's because it's hitting that spot a multiple time of 3. Oh, look, I'm going to hit play. And then there's 4, 5, 6, 4, 5, 3, 2, 1. And so there we go. We can see the multiplicity. And it's really hard to see that just because it is kind of going through like this and coming back out, or going up, kissing, and coming back down. All right, study tip. Let's look at this. Close to a 0, the graph looks like a polynomial function with the degree equal to the multiplicity of the 0. And again, if you look at this, let's go back down to 2. You see that this comes down and makes this nice sharp U. But when we go to 4, it comes down and it's more spread out here. It's a lot more spread out. And if we keep going to 6, you see that even becomes wider as it comes in. So there you go. There are some key things to look at with multiplicities. So describe the behavior of the graph of the function at each of its zeros. All right, so this is, it's going to come and it's going to go through x when x is equal to 0. The graph is going to go through x when x is negative 4, and the graph is going to come up and bounce off of x minus, all right, when x is equal to 1. So I'm just going to put some letters in here so we can get the book answer. You guys could see what the book says and then do part B. So the graph crosses the x-axis at the zeros, negative 4 and 0, and has a turning point at 0 when 0 is 1. So we're going to call that a turning point. It comes, it bounces off, and it turns around. Goes the same direction that it just came from. All right, so do the second part. Notice having x squared here. What does that show as an impact? Does it do anything because it's not outside the parentheses? As I did in my example here, notice my multiplicity is outside the parentheses. What is this x squared going to do inside the parentheses? So that's something for you to think about. Maybe graph this and explore what it's doing. All right, so that is example 2 for topic 3.5, and I will see you in the next video.